Hi, we're back again with an example problem for finding instantaneous slopes at any given point on a graph. And so there's some funky wording in the homework. It's actually kind of bothering me because I feel like it's a little bit subversive to the point of what we're actually doing here. So hopefully you watched last video. If you haven't yet, I highly recommend it because we went through a little bit of a proof to find out how we can find instantaneous slope, or at least approximate really well. And if you'll remember, what we came up with was that if we take the function and plug in x plus h to that function, wherever there's an x, and then subtract the same function with just x as the input, and divide by h, that this is going to give us some approximation for the slope at any given point on a graph. The trick here is that the smaller h gets, the more accurate your approximation is. And as h approaches 0, your approximation is so good, it actually is just considered as truth. So if we take this function that we've designed, and we take the limit as h approaches 0, what you're going to find is that you have the instantaneous slope for any given point on your graph. And this is what this function that we'll come up with is actually called a derivative. It will give you the instantaneous rate of change at any given point on your graph. So anyhow, this problem says let us find the slope of this function of x, which is equal to x squared minus 3x minus 4 at some point, some ordered pair 2, minus 6. And so we have the function, and we have our limit rule, which really I highly recommend you watch the video I just made on this. It's hopefully going to clear a lot of things up as to where this even comes from. So the next step is we're actually going to, for this function, wherever there's an x in this function, we're going to put in x plus h. So I'm going to be figuring out what f of x plus h is. So I look at my f of x, I see an x there. Now instead of just writing an x, I must write x plus h squared, because I'm plugging in an x plus h for the inputs. And so then it's minus 3. Up here it's x, but because we have x plus h, I'm going to put an x plus h there. And then we just have minus 4. And we've now solved what the function is, f of x plus h. Now we're going to subtract the function f of x. Well, we already have the function f of x, so we'll just write it in as is. And then we're dividing it all by h, which we have written here, and we're taking the limit as h approaches 0, which is going to give us instantaneous slope. So there is an algorithm for doing derivatives that will come at some point, and it will make your life a lot easier. But for now, we're using this proof of what a derivative really is to solve for derivatives. So there's going to be a lot of algebra. So here we need to square this term. X plus h squared is going to be, if we FOIL it out, we'll find it's x squared plus 2xh plus h squared. So we just FOILed out this term. Now we're going to distribute the minus 3 into this term. That's going to give us a minus 3x minus 3h. And we still have the minus 4 there. Now we're going to distribute the minus sign into all of these three terms. And we're going to end up with minus x squared plus 3x plus 4. Alright, so we are at this point, and it's all divided by h. And now we're going to look to see if we can cancel anything. So we'll look through here, we'll go, okay, I got an x squared here, there's a positive x squared, a negative x squared. Well, the positive and the negative are going to cancel. Right here we have a negative 3x. Over here we have a positive 3x. So those are going to cancel. Right here we have a negative 4. Here's a positive 4. Those are going to cancel. And what we're left with is this function h squared minus 3h plus 2xh all over h. And we're taking the limit as h approaches 0. And this trick's going to pop up a lot when finding derivatives this way. We're going to pull an h out of each term on the top, and we're going to make it look like this. So we're essentially factoring out an h from each term. And that just leaves us with an h minus 3 plus 2x, because we pulled an h out of here, out of there, and out of there. And this is all divided by h. Well, h divided by h is 1, so those two cancel. And now we have the limit as h approaches 0 of h minus 3 plus 2x. Well, as you can see here, the limit as h approaches 0 when h is in the numerator and it's just being added to other things, we can actually just go ahead and say that, well, we want h to be 0, so why not just make it 0? We're not breaking any rules there. And what we're left with is 2x minus 3. And that is our derivative function. So, now we go back to the beginning of the problem. This function right here, let me make some room. This function that we just derived is known as the derivative. For now, we're just going to call it, let's go ahead and call it f prime of x. And it's equal to 2x minus 3. We just solved that. So if we want to know the slope at any given point on this graph, we just need to input an independent variable in for x here. So we look up at our ordered pair. We'll notice that it's a 2. So we're looking for what the slope of this function is when x equals 2. So we're going to go ahead and take 2 and plug it in for x. So we're looking at f prime of 2. So we go ahead and plug in 2. 2 times 2 is 4 minus 3 is 1. And therefore, the slope equals 1. We call it m. The instantaneous slope equals 1. Now, I think there may be another part of this problem. Let me check. Now it wants the equation for the tangent line. All right, so we found the slope. The slope is 1. So now it actually wants us, because this slope that equals 1, if you'll remember, to have a line, we need y equals mx plus b. Now we have m, we don't have b yet, so we're going to have to solve for this specific line on this graph. And to do so, we're going to, I'm not going to draw the graph exactly as is. It looks like some sort of a parabola facing upward. So we're something like that. And if we wanted to know for this slope passing through some point P, so we know the slope, we know the point P, and we're trying to figure out if we wanted to make a line that was tangent to this part at that point, what we would do is we would say, well, I know my x and my y coordinate for the point, and I know my slope. So all I need to do is I need to say, okay, so my slope is 1. I'm going to plug that in, and I know my ordered pair is minus 6 in the y, and my x for that ordered pair is 2. And then I don't know b yet, but I can solve for it. So 1 times 2 is 2 plus b equals minus 6. We'll subtract the 2 over. We get b equal to minus 8. Well, now we have m and b, so now we have that tangent line. It's no longer just free-floating slope, right? Now we actually have a place to put it. So, I mean, imagine all the curves with slope 1, right? There's this line has slope 1, that line has slope 1. There's actually infinitely many lines with slope 1. What this b does is it tacks us down, all right? So we're at negative 8, so this is the y-intercept. y equals negative 8. And so at this point, we're good to fill out our y equals mx plus b. Y equals the slope we solved was 1, so y equals 1x plus b is a minus 8. So there we go. This I hope this helps, and please continue to send requests to see videos. Thank you and have a nice day.